There are several reactions that we can do with amines, especially using nitrous acid. So if you recall, we used a long time ago in aromatic chemistry nitric acid, HNO3, or we have nitrous acid, nitrous acid is not stable, and if we treat an amine with nitrous acid, this can make sodium nitrite in solution with a strong acid, such as HCl or H2SO4. So we'll have sodium nitrite forming, which is what we see here. There's no positive charge here, so remove that from your slides. So we have sodium nitrite. Once that reacts with HCl, that can give us NaCl plus nitrous acid. Which can do a proton transfer. Water will leave, and we form this nitrocesium ion. And that is in resonance with this structure here. All right, so once we have a nitrocesium ion, I won't go through the mechanism of this, but that can react with other amines to form a couple of different products here. This is nitrosodimethylamine. Which is found in many food products, including cured meat, fish, and beer. We have N-nitrosopyroladine. This is in fried bacon. And this is N-nitrosonornicotine. And that is in tobacco smoke. So you may have started to think that these nitrosamines were things that added delicious flavors to cured meats and bacon, which it does, but it's also found in tobacco smoke, and it just happens that nitrosamines are known to be potent carcinogens. So if you hear people talking about these nitrates in beers and cured meats, some of those nitrates are what is causing the nitrosamine. Okay, but we can use this nitrosamine chemistry to our advantage. These react with Aryl Diazonium ions, and these alkyl diazonium salts are extremely reactive, and they can be explosive because the nitrogen, or N2, is going to be the leaving group in these reactions. Aryl diazonium salts are a bit more stable, and they're synthetically versatile. So if you have aniline, we can use NaNO2 or HCl. That will form the nitrous acid and then the nitrosonium ion. And we just sometimes refer to this as HONO or HONO because of that NO2 in there. Once you have aniline, you react it with the HONO. That forms this diazonium salt that you see that we were talking about here. And the diazonium salt we can use to quickly put on a halogen or other groups here. So if I react it with any copper reagent with another ion, that will get us that ion. For example, if we add copper bromide to the diazonium salt, we get bromobenzene. Copper chloride, we'll get chlorobenzene. Iodobenzene, benzene nitrile. So treatment with a copper salt is going to give us the aryl halide or a nitrile. So if we look at these synthesis problems here, to add a nitro group, if you recall, we would use HNO3 plus H2SO4, and this isopropyl group is going to direct us to the para position. So we're going to get a nitro that's para. The iron will reduce it to the aniline. Sodium hydroxide is part of the workup with the iron. And then NaNO2 is the reagent that you use, or this HONO, in order to convert it to the diazonium salt. And then we add copper cyanide, do a hydrolysis, that will get us the carboxylic acid. If you have the diazonium salt, we can just add water and heat to that to get phenol if you wanted to do that. Or you can also use this H3PO2 to put a hydrogen back on there. Using the synthesis, amines can be used as a directing group. Diazonium salts can also be attacked by aromatic rings with an activating group. This is using the electrophilic aromatic substitution reaction. So you can take a benzene ring and react it with the diazonium salt. You get a stabilized sigma complex. Then you have this compound here. And these diazo compounds this is an azo coupling that produces azo dyes. And varying the substituents on the rings can affect the specific dye colors. Heterocycles are ring compounds that incorporate a non-carbon atom into the backbone of the ring. So we can see this is a heterocycle here. Here's a heterocycle. This is the structure for Nexium, which is a proton pump inhibitor for ulcers and acid reflux. And this is the structure of Viagra with the several heterocycles here. And I'm sure most of you know what Viagra is used for. These are 4 different nitrogen heterocycles. Imidazole is something that we've seen may be used as a base. There's 2 nitrogens there that are basic. Pyridine is also used as a base. Pyrimidine is in DNA. And then we have histamine here. Pyridine and pyrimidine can undergo electrophilic aromatic substitutions, just like benzene, but the yield is not as good. All right, so we want to look here at what these reagents will do. NaCN with the halogen here. I'm going to do an SN2, reverse the stereochemistry and get nitrile. And then we're going to reduce with the lithium aluminum hydride. That will reduce to the amine. And that's all we would get for that structure there. Right here we're looking for a synthesis. There's no rules on the first one, but if we want to make a secondary amine, we want to do a reductive amination. And there's going to be 2 ways to do that. We can start with this ketone. Add this amine. Sodium cyanoborohydride. And that will give us the target molecule. So in that one, this is the part that is the carbonyl. Or we can use this as the carbonyl. There's our amine and then NaBH3CN. So there's 2 ways to do that one. All right, this other synthesis will be a little bit more involved. Here we're forming an amide. So I'm going to go through a nitrogen. I need a nitro group here first. So I will start with HNO3, H2SO4, which will give me NO2. I'm going to reduce that. Using tin chloride. That will give me NH2. And since I'm not given any rules here about what I can and cannot add, I'm just going to use an acid chloride. To put that one group on there. And so that's how you would do that synthesis.